We are now going to move on to chapter 6, section 2, which is all about weather patterns. There's a lot of information in this section. I actually divided it up into 3 sections, so that's why you see 6.2a. And obviously we're going to have B and C. It's just so much. Like I said, this is such a nice big chapter with a lot of great information in it. Today we are going to be talking about water in the air and then cloud formation. So most of us watch the weather, or have watched the weather at one point. Maybe you get forced to watch it by your parents or your grandparents. But I love watching the weather. And like I've been saying earlier, we live in northern Minnesota, so it changes all of the time. Now, the people that do this as a job, they are called meteorologists. And I put 2 sort of kind of famous meteorologists on there. One's obviously on a national level, and the other one, my local favorite meteorologist, Justin Lyles. I really like him. I think he does a great job. They're what we call meteorologists. So they're people who use scientific principles to explain, understand, observe, or forecast Earth's weather. So what they're actually doing is they're studying meteorology. So meteorology, anytime you guys see ology on the end of a word, it means study of. So it's the study of weather. Now, yes, they are meteorologists, but they are not the only meteorologists. So if you want to become a meteorologist, it doesn't mean you're going to necessarily stand in front of a camera like they do. There's meteorologists that are working behind the scenes at local places. NOAA, so the National Oceanic and Atmospheric Administration, there's scientists there all the time. So it doesn't necessarily mean that you have to be on TV, because there's people sending us out alerts and forecasts, and it's not always on TV, but they're all doing the same thing. They're all explaining, understanding, observing, forecasting weather for us. Many meteorologists have college degrees in physics, chemistry, or mathematics, or meteorology. So most of the time you're going to go to college for 4 years and you're going to be studying these different things. So it's not always necessarily think of weather. There's a lot of things that we learn about in science class that actually affect the weather, and they're also important to learn. Even math, believe it or not. So water in the atmosphere. When it gets warm outside, higher temperatures cause liquid water molecules to move faster. So they put energy into those molecules. Those molecules get moving faster till eventually, if they get enough energy put into them, they will break free from the liquid state. They will go into the air in gas form, and when they are in gas form, we call that water vapor. So they then turn into water vapor, which is just liquid water in gas form in the atmosphere. Another side thing is, as you see in the bottom right-hand side of the slide here, as atmospheric pressure increases, evaporation decreases. So we've been talking about air molecules pushing down. So if you have air molecules pushing down on a surface, it's going to be harder for those molecules to break free and become a water vapor in the air. So pressure can affect that evaporation rate, or the rate at which the water molecules go into the air. Higher pressure is going to push down on those molecules and make that harder. You're going to have to put more energy in it to get those moving. If you've ever paid attention to the weather too, you may have heard of this before. It's called the dew point. The dew point is the temperature at which more water condenses than evaporates in an air mass. And we have to put in parentheses behind there. It's got to be at a constant temperature. So it's kind of like, at what temperature is that water going to come out of the air? That water vapor that we were just talking about, is it going to come out of the air? Now, depending upon what the dew point is, it can feel different for us outside. You look at this little dew point index as you see on the slide here. If it's above 76, those are those days in the summertime where you're just like, oh my gosh, I can't even move outside. I didn't even do anything physical and I feel like I'm sweating. That means there's a really high dew point outside. The temperature at which more water vapor condenses and evaporates is much, much higher then. When these water droplets go in the air, they can form what we call clouds. And we all are familiar with clouds. If you're a daydreamer, you're really familiar with clouds. So clouds, all they are is water droplets that have condensed in the sky. So we talked about the water cycle and how water can condense in Earth's atmosphere. When that happens, it can form clouds. Why do we have all these different types of clouds? Because different weather conditions cause different types of clouds. So all of the ones you see on the right-hand side there exist, all those different types of clouds, just based on what are the conditions that they formed at. Overall, clouds form then when air rises, it cools, and it condenses. That's how we get clouds. Air rising, cooling off, and then condensing. So those water vapor molecules that you put up into the air get cooled off and turn back into a liquid. So how do we get air to rise? We have different ways we can get air to rise. I'm going to show you some pictures here of that. Here's the first one, and it's just straight up convective lifting. So you have warm air is going to rise up off the ground. It's going to cool off and then form a cloud. So that's convective lifting. Remember, warm things rising. Orographic lifting, you can see in this picture, we have this sort of weird green thing. So this would be, think of a large mountain, large land mass it has to move over. So that air, as it moves over that air mass, it's going to go up in elevation and then it's going to cool off. So you will often see clouds. If you're talking about really large land masses, like think of mountains and things, you're going to see clouds up there. And now you see why, because of what we call orographic lifting, that air getting pushed up. Frontal lifting. So we haven't talked about fronts yet, but a front is going to be a different air mass. It's got a different temperature and maybe a different moisture content. Is going to come in contact with a different air mass, different temperature, possibly different moisture contact. When they hit each other, when they run into each other, they can sometimes force things up in the air, and that's going to also cause possibly condensation. Finally, convergence, look at the prefix there, converge. What happens when things converge? They come together, right? So if I have two air masses run into each other, they can push things up in the air and cause clouds to form. So we can have different ways the air can rise, as we just saw, convection, land masses, fronts can cause them to move up, air masses running into each other, but whatever the case is, the air is going to rise, it's going to cool off and condense, and that is how we get clouds to form. So different types of clouds form, like we said, based on the conditions in the atmosphere. We name clouds based on two things. They're named by their location in the sky or location in the atmosphere, and what do they look like. So we look at where is it at, and then what does it look like. Cumulus clouds are puffy white clouds. They indicate fair weather to us. So if you go outside and you're planning a picnic for the day and you see this, great. You're probably going to be good to go. These are the ones that are going to be really easy to make out of cotton balls. Those are your cumulus clouds. Now you'll notice on the bottom of the slide there, those don't look as nice. That should be kind of an indicator to you when I look at that and go, maybe I should rethink my picnic. When you see those clouds are called cumulonimbus clouds. So when you see the word nimbo or nimbus inside the name of a cloud, it means that it's producing some type of a precipitation. So cumulonimbus are clouds that produce rain. They're often thunderstorm clouds, so ones that are going to produce a lot of rain in a short amount of time. But anytime you guys see those words in there, nimbo or nimbus, that means that it's going to probably produce precipitation. Stratus clouds, the word stratus means layers. These clouds form in layers. They look like they cover really large areas of the sky. You're not going to see a lot of blue coming through or anything on the sky when stratus clouds are out. Nimbostratus clouds produce continuous rain for a long period of time. There's that prefix for us again, nimbo's inside of there. So nimbostratus clouds produce continuous rain. That's definitely a non-picnic day. You know, it's probably not going to be nice. Cumulonimbus clouds, they don't last as long, so you're maybe going to be okay. If you're going to see nimbostratus clouds, odds are you're going to not see any nice weather for that day. Cirrus, they are thin, feathery clouds. They're formed at really high altitudes. They form during really strong winds, and they usually indicate to us that there's going to be a change in weather. Because you're having an air mass moving in, usually we see a change in weather. So if you see these really cool cirrus clouds high up in the sky, the weather's probably going to be changing that day or the next day. Now we can also, I said, we'll look at height. If clouds form up really high, we call them cirro. They'll add that prefix to it. If they're in the middle, we call them alto. That should sound familiar to you if anyone's in choir, right? If you sing in the middle range, you can be an alto. Or if, let's say, you play the alto saxophone, that's the saxophone that's in the middle range. And then finally, if they form really low, we call those strato. You'll add that prefix in on the beginning of it. When we name clouds, we never like to be redundant. So they're not going to say stratus clouds, cirrus clouds. They're not going to throw those on there. So looking at this picture here, look at the cumulus clouds on the left-hand side. If I have cumulus clouds that form really low, then we could call those stratocumulus clouds. Remember, strato means low. If they form in the middle, altocumulus clouds. And then finally, up really high, cirrocumulus clouds. I have cumulonimbus clouds. You can see on the far right-hand side there, there's some stratus clouds. Stratus clouds formed in the middle, altostratus. So we're going to look at where they formed to name them, and then what do they look like. Here's just another picture. I like this one because it actually shows you real pictures of clouds, not the cartoon ones like we just saw. But there's the different layers of them. Is it a low? Is it a middle? Is it a high? And then what does it look like? So what type of cloud type would that be? Is it a cumulus, a cirrus, or a stratus? I hope you said stratus because you are correct if you did. How about these guys? Cirrus, cumulus, or stratus? They're puffy white, so they must be cumulus. Finally, these are those thin, feathery clouds. They're formed really high up in the atmosphere, form strong winds. I would say cirrus clouds. Okay. The last thing the chapter talks about is precipitation. So if clouds get enough moisture content inside of them, and if conditions are right and temperature is right, we can get precipitation forming. Rain is the result of a cooling air mass with water inside of it, and the temperature has to be above 32 degrees Celsius, or 32 degrees Fahrenheit. If it's above 32 degrees Fahrenheit, you're going to have rain. Tiny droplets, small amounts of water, can also form a cloud or fog, and then if there's enough of it, it's going to fall down to the ground. Depending upon how much, depends upon how much rain is going to fall, right? More moisture, more rain. Less moisture, less rain. And we can thank gravity for this process. If we didn't have gravity, we would not have rain. Snow. So now if the temperature is below 32 degrees Fahrenheit, we're going to get snow forming. This week, we're going to be watching a couple cool videos on snow formation and ice crystals, really cool stuff. So snow usually forms when both ice crystals and water droplets are present in the sky. So the temperature has to be below 32 degrees Fahrenheit. The water droplets attach to ice crystals, and those ice crystals form these beautiful structures there. When the ice crystals are large enough, they fall to the ground as snow. Now, depending upon what the conditions are like outside, we get different types of snow. And I think we know this living where we do. We know that not all snow is the same. There's some snow that's great for snowmans. There's some snow that's not. There's snow that's hard. There's snow that's soft. There's all different types of snow. So we have different types of snow that forms based on how much water is present and then based on the temperature outside. So you can see this kind of really cool graph here showing us what different types of snow is going to form. Freezing rain is rain that freezes once it hits the ground. So I like the picture on the bottom of the slide there. So freezing rain would be lower right-hand corner. Let's say you have snow falling, it's going to melt, and then now once it hits the surface is still really cold and it's going to freeze. This is bad stuff. This is the not fun stuff if you're a driver outside because it looks like everything's fine when really it's not fine. And I don't care what type of vehicle you're in, nothing drives well on frozen rain. I don't care if it's four-wheel drive or not, it's not going to go very well. Now sleet is different. Sleet is not freezing rain. Sleet is what happens when snow that melts in the air and then it refreezes before it hits the ground. So look at the picture on the left-hand side. Snow's falling, it's going to melt, then it's going to refreeze before it hits the ground. If you look at the picture on the top now, sleet's a little bit different because sleet will actually bounce off the surface with some accumulation. So it's almost like hard snow if you want to think of it that way. Finally, we can't talk about precipitation without talking about hail. In those really large cumulonimbus clouds, sometimes conditions exist where the rain gets pushed back up in the cloud. If it's colder up there, it's going to freeze and then it's going to drop back down because of gravity. Let's say I have another updraft. Oops, it's going to go right back up. It's going to freeze, come back down, get more water. So it's kind of like Mother Nature making an ice ball. Not very good, right? But really that's all that's happening. You just have these convection currents inside the cumulonimbus cloud that's going to create hail. The more times it goes around in that convection current, the more bigger the hail is going to be. And hail can get to be really, really big in size, softball size, baseball size hail. That means that hail really took a trip on the roller coaster ride inside of that cumulonimbus cloud and was able to form. And that stuff is not good. As cool as it looks, that guy's holding it, it's like, wow, that's neat. That is not good for property. That can cause a great amount of damage to cars and cause even a great amount of damage to homes if that stuff is hitting your roof. So hail is pellets of frozen rain that fall from cumulonimbus clouds to the ground. Often we know it's associated with really severe weather. If we have really big storms come through, then we are going to be getting hail. So clouds are formed when water vapor rises, condenses, and cools off. And we get all of our different types of clouds because of where are they in the sky, low, middle, high, and what conditions existed to cause those clouds to form.